Hello and welcome to this realist simulation What's New presentation for our first release of 2024. My name is Charles Turcanose and I am the product manager responsible for Realist's 3D computation fluid dynamics suite VECTIS. Our fluid product, VECTIS, is a high-fidelity expert 3D CFD solution for tackling challenges in ICE design, thermal management, and general fluid systems. With VECTIS, our customers can accelerate virtual product development and take advantage of the latest innovation and R&D. Realist products put customers at the center of decision-making and deliver a personalized experience while minimizing their development costs. These 5 pillars of our product strategy firmly put the customer at the center of our product's development. Today, it is my pleasure to introduce the new and exciting features of the 2024.1 release of VECTIS. I will also give you an overview of how these features can help you achieve your R&D and CAE modeling objectives. The 2024.1 release is packed with features addressing new simulation challenges, enhancing usability, and helping you speed up your workflows. With this release, we are continuing providing enhancement on the theme of accuracy, usability, and speed, all of which underlie realist simulation fluid products. Under the new Applications and Functionality header, we have bolstered our modeling capabilities for rotary engine simulation. Our geometry improvements also enable the automation of even more complex pre-processing workflows. And the transition from our legacy pre-processing tool Phase 1 to our geometry is made seamless through the import of boundary data stored in tri-files. Finally, additional options for rotational velocity specification offer an increase in robustness when simulating rotating fluid domains or rotating boundaries. In the user experience category, a number of improvements are released. These include post-processing robustness improvement for flame speed table generation, leading to more accurate tables. This also includes a significant speed-up of quasi-steady-state simulations, including passive scalars, obtained through automatic selective equation disabling. The creation of library components supports a seamless exchange of modern components between different setups or team members. And finally, usability enhancement for simplifying the construction, checking, and navigation of large case tables have been introduced. Under the workflow enablers, we have also added a number of session parametrization improvements, a game-changing improvement for RPost, allowing for bulk curve data source modification. And finally, the seamless integration of the VECTIS toolchain in the wider pre- and post-processing third-party tools ecosystem is enhanced through the support of additional Nsight format export option and through the grid imports from Star CCM Plus and Beta CAE NSA newest versions. Let us now dive a little bit deeper into a selection of these features highlighted in bold. Towards the end of this presentation, we will also cover briefly other enhancements available with this release. Rotary engines, known for their compact size and high power-to-weight ratio, play a crucial role in the aerospace industry, particularly in the unmanned aerial vehicles applications, where lightweight propulsion systems are essential. They are also gaining traction as alternative power sources in hybrid powertrain systems, serving as really effective range extenders. With this new release, VECTIS makes innovation in UAV propulsion accessible by allowing even more accurate simulation with a streamlined setup process. The key enhancements unlocking innovations are an advanced ignition strategy support to accurately simulate intricate ignition strategies for which the local conditions may lead to very different kernel development histories. We have also added a fine control of timings based on triggers, offering an easier configuration and greater flexibility in setting up complex injections and ignition strategies. And finally, a comprehensive heat release rate reporting provides a deeper and more detailed understanding of the combustion dynamics in the various engine lobes. These improvements are not limited to rotary engines, but they are also available for other market sectors, such as reciprocating engines. The simulation results shown here are provided courtesy of AIE, a rotary engine manufacturer based in the UK. In this release, we are continuing along the path of enhancing the scripting capability of our geometry to enable automation of IC preprocessing workflows. This release takes a step further and adds new operation allowing splitting of painting boundaries for an accurate application of the boundary conditions and monitoring. For example, in some applications, it is useful to split the flame face, the liner, and the piston boundaries to better model the asymmetry of the flow and the behaviors of detailed physical sub-processes such as wall film accumulation. In the current release of our geometry, it is possible to achieve this by utilizing the context menu in the face painting panel. The commands issued are logged and can be scripted easily to run the whole operation in batch mode. Other operations added to the scripting interface in this release include painted face renaming and a common interface for painting of body surfaces. At Realis, we understand that the transition from established workflows to new ones has associated costs. Therefore, we are always looking for opportunities to make it easier for our users to take advantage of the new technology. In this release, we have enhanced our geometry to import boundary type and motion data from Realis tri-file used in our STL preprocessing tool Phase 1. We have also added the possibility to import and export volume mesh definitions into the text input files format for vMesh. These new features help our current users transfer their workflows to our geometry and take full advantage of his CAD preprocessing, surface meshing, and volume meshing capabilities. Pre- and post-processing tasks take a substantial part of the overall modeling effort in a CA process, and in CFD in particular. Simplifying complex engineering tasks with streamlined and efficient workflows saves time and allows engineers to concentrate on the analysis of the key results extracted. In this release, we are adding additional controls to enable a fast extraction of results by introducing a mechanism to modify curved data source in bulk. This feature enhances a similar option existing for the topology and dataset panels and allows to quickly analyze results coming from various similarly structured data sources with just a few clicks. The video demonstrates the use of the new feature to quickly add curves to a plot with data coming from different computations. First, the original curves are copied and modified to be sourced from the file K02 and K03 instead of K01 using the new replace source in the file context menu. This plot is then copied to a new page and all curves are selected before the variables plotted is changed from pressure to temperature using the replace options of the dataset context menu. Finally, we are moving to the inlet-outlet, where the pressure and velocity are plotted at the outflow. They are copied to a new plot, and the boundary is changed from the outlet to the inlet using the replace option of the topology panel context menu. Navigating through complex simulation projects involving a large number of components can be daunting. In particular, ensuring models' consistency between different teams, potentially relying on different tools and workflows, may be challenging. This becomes particularly acute for components requiring numerous user inputs and variables. The 2024.1 release extends the existing library features of Rdesk to the VECTIS GUI, empowering engineers to collaborate seamlessly with other team members and reduce the occurrence of potentially costly mistakes in their setups. This feature enables the publication of canvas elements such as fans, injectors, and sparks to user-defined libraries, which provide a convenient way of reusing and sharing predefined model elements. This new feature is available through the context menu when a compatible element is selected on the canvas. This video demonstrates the addition of a fan to an existing user library. We can see that the fan library is now loaded as part of the active library of the session. We then move to another session and load the fan library. When inspecting the library, we can find our new element created, and we can import this element onto the canvas and then link it with the fluid domain. Other elements can be easily drag and drop onto the canvas to add them to the session. The previous developments and ongoing enhancement of the VECTIS GUI session parameterization support the definition of large parametric studies or design of experiment sweeps, in which the variations of numerous parameters may be investigated. Managing the complex case table resulting from such a large parametric space, where the number of cases may range from a few to hundreds of cases, present challenges. In particular, the potential for input errors leading to lengthy troubleshooting. In this release, we introduced the case table profile feature to tackle this problem by offering a visual representation of the input parameters values against the case ID. This powerful tool supports the plotting of multiple parameters while intelligently grouping variables with similar units on common axis for a clean visualization. This allows a large time saving in the validation of the case tables, bolstering confidence in the configuration and drastically reducing the possibility of user errors. This video showcases the loading from an Excel spreadsheet of a large parametric sweeps emulating a possible experimental measurement campaigns and the application of the new features in effectively tracking the error present in this complex table. We can start inspecting the engine RPM as part of the case table, and when visualizing the profile, two cases immediately stand out as potential errors. These cases can be investigated and corrected. A similar process is repeated for the start of injection and start of combustion parameters, which are the two other parameters of this study. multiple parameters can be plotted simultaneously, as shown here. And finally, an additional enhancement brought to the case table as part of the 2024.1 release is the storing at the session level of the column width, such that it is recovered when reloading a session. We have also added a context menu that allows for the automatic resizing of the column width to fit their content, which improves the navigation of the table when parameter values contain long expression or file names, for example. Apart from the headlines, this release contains many additional enhancements to VSolve and the wider VECTIS toolchain. In particular, we can mention the suit scaling for Logi Advanced Chemical Solver that allows the calibration of the suit models when using the Logi suit model. A VECTIS session comparison tool enables the direct comparison between VECTIS session content and export the output to a CSV file for an easy formatting in spreadsheet, for example. Supplementing the existing path conversion in the session, the user can now decide how the paths are written to the input file, whether they will be written all in absolute, relative, or unchanged from the session, which allows for a more flexible setup, in particular when doing parametric studies. As mentioned previously, a significant speed-up of quasi-steady-state simulation, including passive scalars, is brought about by freezing automatically the flow equations upon reaching convergence, while enabling the passive scalar equations to reach their own convergence level. In addition, when equations are frozen, their residuals are now written to the report file to ensure a smooth loading in our post. Finally, parametric expressions and parameter tooltips are now enabled in tables in the GUI, at the exception of concentration tables. For our geometry and our viewer, specific improvements include the scrolling bar present in the tree now has a minimum height to ensure a smooth navigation, even in complex geometries composed of hundreds of bodies or components. The import and export of volume mesh definitions into the text input file format for vmesh has been added, and surfaces can now be split by plane for an accurate description of boundary conditions and monitoring. This operation, as mentioned earlier, supports scripting. Then, the RDES color palette, as defined in the global preferences, is now used for the boundary of faces set colors. And finally, a RViewer enhancement allows to retain the variable units in addition to the existing feature of retaining the ranges. Under the Tools and Utilities categories, numerous enhancements have been implemented in the combustion toolbox. This realist simulation Swiss Army knife of kinetic tools leveraging the power of Cantera's suite robustness was significantly improved, in particular the laminar flame speed table generation utility. Furthermore, all the tables shipped with the installations have been updated to take advantage of the most recent improvements. Flame speed tables for diesel surrogate ID and for biodiesel hydrogenated vegetable oil surrogate have also been provided with the installation. The CGNS and HDF5 libraries have been upgraded to version 4.40 and 1.12.3 respectively to support the seamless integration of VECTIS toolchain within the wider pre- and post-processing ecosystem of third-party tools. In particular, this allows the conversion of grades generated in the most recent versions of StarCCM Plus and Beta CA ENSA grid generation tool. Finally, let us have a brief look back at the key features of the past two releases which may be of interest to you. In particular, the new flame speed models for lean and very lean hydrogen combustion modeling, a decoupled knock tendency analysis tools based on detailed kinetics, or a unique fuel tracking per nozzle for liquid fuels capability. In terms of user experience, we have recently introduced the parametric solution in the VECTIS GUI, advanced transformations for our geometry, and swapping timing defined by triggers. Finally, in terms of workflow, we have released a fully scripted CAD to mesh workflow based on our geometry, as well as a full Python scripting automation of both session and post-processing. Our post was also enhanced to easily and seamlessly post-process parametric sweeps, while the import and export possibility for case and parameters table using spreadsheet was added. In summary, VECTIS is continuously improving to help you address your most pressing engine challenges and to make it the world's best CFD toolchain for powertrains. I hope you have enjoyed this short introduction to the new features of our first release of 2024. Our team is here to provide more information about these features and help you adopt them to enhance your CAE processes. If you have any questions, please contact us at support@realist-simulation.com. Thank you for your attention.